distribution model for a mean. Now we move on to the second example. It's a sampling distribution model for a proportion. So provided that sampled values are independent, there's conditions need to be checked. And we're not going to explain the details today, the time constraints. The sample size is large enough. The sampling distribution of p hat is modeled by a normal model. So now we've got an idea. The sample size, if it's big enough, what kind of model you can get?
Normal model.
Normal model. And then another result is the mean of the model. The mean of the sampling distribution would be equal to?
Very close to the mean of the population.
Yes. Or the proportion of the population will be equal to? Yeah, we say proportion of the population. Proportion of the population, because we are describing the categorical data. Okay, so we can see visualize this sampling distribution, and then the sampling distribution, they're still centered around the two proportion, and then they have some variation. The variation is centered around this two proportion. This is 1 standard deviation away, 2 standard deviation away, 3 standard deviation away. So here 1 actually refers to those z-score. Like here, this data point, this score should be +1 because it's on the right side and is 1 deviation away from this 2 proportion. Now, suppose that about here it's a problem, and we use this problem to understand how to use the sampling distribution to model the relationship between the sample and the population. And then there are about like 13% of population is left-handed, for example, in our college. And then there's the auditorium, and then they build 15 lefty seats. Like they have seats and then you can write on the left. And then suppose there is a class of 90 students. Now what is the probability that there will not be enough seats for the left-handed students? So let's see so many numbers there. We don't get distracted by this 200. Actually, they're distracting you. Let's think about what is the sample size?
90.
Yes, 90 students. 90 students actually is less than 10% of the whole college, right? And then, so the question really actually is asking you, this 90 students that enter this classroom, which only have 15 left-hand seats, and then what is the probability that there are more students, more than 15 students who are left-handed students, we cannot find the left-handed seats to sit in, right? Okay, so then we will know the 2 proportion P. 2 proportion P is true proportion. It means the proportion of the whole population is 13%, right? And then the sample proportion actually is 15 divided by 19. That is around 16.7%. And then we use that formula we just learned from the previous video slide, and they talk about how to calculate their variation or the standard deviation. So this is a true proportion, and 1 minus this divided by the square root of the sample size, and we know the standard deviation for the sample p hat is like this. Now we visualize this whole distribution. We will see the true proportion is still at the sampling distribution to proportion is the same as the proportion of the population. It's at 0.13. And then this is the data point where if you more than this data point, like then you are very likely the class of 90 students that enter that classroom is likely for them to cannot find enough left-handed seats, right? So we need to calculate the z-score of this point. How do we do that? And this is another formula we have learned before. We use the population, we use the sample proportion minus the population proportion and divide it by the standard deviation and we will see this is how many unit of standard deviation away from the true proportion, and we found this is 1.06. Okay, and then in statistics, we know that from the Z table, you can find out the corresponding probability. The probability of the Z-score plus 1.06 is that much. It's 14.46%. What does that mean? So the answer for this problem is that there is about a 14.5% chance that there will not be enough seat for the left-handed students. So to use that application in the real life, what does that mean? Is that 14%? Around 14% big percentage?
No.
Yeah. So it's not a big percentage. So it's not necessary for the university or the college to build more seats, right? So we just use this example to illustrate how assume a sampling distribution to estimate the proportion of the whole population. Okay, main point 2. Can we read it together?
The central limit theorem says that as sample size increases, distribution of sample means or sample proportions from different samples is more normal and less variable. The mean of the distribution of all possible sample means the population mean, and the standard deviation of this distribution is the population standard deviation, or the square root of p times 1 minus p divided by the square root of the sample size.
So here introduced like 2 models, and then how to calculate the standard deviation for those 2 models. The standard deviation of the mean is, remember that, it's the standard deviation of the whole mean divided by the square root of the n. That is for the quantitative data. And for the categorical data, we can say P. There's a percentage of the true population multiply its failure proportion and divided by the n. So they basically talk about this 2 ways of calculate the standard deviation for 2 different models. The 2 different models are coming from the same, based on the same theory, which is called the CLT. Okay, so in SCI point, we say the mathematical order and precision that underlies all activity and variation in the ever-changing observable field of natural law has its basis in the unseen abstract field of nature's intelligence. No matter how variable the samples are, still we can trace back to its source, to that unchanging and without variable field. And then scientific research about TM finds that nature's intelligence can enliven our brain's total functioning so that we can have broader comprehension and sharper focus, and we will not get lost in those proportion population sampling distribution. Okay, so the summary for today's class, we talk about the CLT, this theory, and we talk about how to based on this theory, and we assume 2 models. And one model is the sampling distribution for the mean of the population. The other model is the sampling distribution for the proportion of the population. And then use this as a gap, we can model the relationship between the sample and the population. So, any key terms you remember come to your mind?
Central limit theory.
Good. What else?
Population sample.
Population sample.
Sampling distribution.
And in the unified field. And then we know the central limit theory is a theory. And then this theory gained momentum or the dynamism through the process. from that we can draw some conclusion, which provide a statement or very valuable information for decision making. They all share this common ground that source the unified field, which is the unchangeable long variation field. Through the TM meditation, we can directly experience that long change nature. And then with lots of people meditate together, practice TM and TM City program, we can enliven that invincibility. That invincibility merge into the outside world as the order and harmony. Unity. On the surface level, central limit theorem describes how sample mean and the proportion vary for all possible samples of a given size. And the deeper level, this theory, CLT, allows us to know how sample means or proportion of the whole population are distributed even when the population distribution is unknown. Even when the parameters such as the mean and the standard deviation is unknown, we can use sample distribution to model it. Thus, it provides a foundation for drawing conclusions about the mean or proportion of the whole population on the basis of data from a part sample of the whole. Think deeply, and transcendental consciousness is a long variable field of wholeness, which is the basis of all partial values of life. Impulses in the transcendental field, the liveliness of awareness at the source of thought moves the field of all possibilities into specific expressions of nature law, wholeness moving within itself. In unity consciousness, a person experiences all processes of transformation in terms of the long changing basis of one's self. Thank you.
All right, let's give some feedback. What did you do well?
Very lively.
Yeah, I like the way you organize the class. It's very clear and you talk confidently. And the smell, your eye contact, yeah, it's very good.
Thank you.
And